Hello, class. So we are now on section 2.6, which this one might be kind of a long one because this is about combining functions. Or basically, we're going to be doing algebra with functions. Okay. So for the most part, functions have names, right? Like this is f, right? This is g, right? This is the name, right? And then this is what you plug into the function. Okay. I find a lot of people get confused, okay, because they think this is multiplying and it's not, okay, right? This is function notation. All right, so we can make a new function, we can call it h, okay, where it is literally just f plus g, okay, of x, which is equal to if I just took f of x and added g of x, okay? So I want you to think about this thing as just a new function where f plus g is its name. Okay, it's not really doing the adding, okay? Because math people don't actually ever do this h part for the most part, okay? So we're gonna be able to do f plus g, f minus g, f times g, so fg, okay? And f over g, or f divided by g. Okay, so these are four new functions, okay? And how we get them is pretty self-explanatory, okay? So this one you just add them together. This one you subtract. This one you just multiply them together. Okay? And then this last one you actually just divide them. Okay, so now I have to talk about these functions' domains. So these three functions, okay, they all have domain A intersect B, okay? And I probably should have labeled it, so like F has domain, call it A, and G has domain, call it B. Okay, so the domain of these three are the domain of the intersections of each of the separate ones, okay? So this one though, this one is special, the division one, because remember when we divide, we have to worry. So this one has domain, okay, equal to A intersect B and G of X cannot be 0, okay? So you also have to double check that G is never 0, okay? All right. So let's just do some examples, okay? Because it's honestly not that difficult. So here I'm gonna have f. It's gonna be x minus 1, okay? And I'm gonna have g, and it's gonna be the square root of x, okay? So first of all, we can find their domains, right? So f's domain is not 1, right? So it's this. And g's domain is positive numbers, okay? So f plus g of x is going to be f of x plus g of x, okay? Which this is f. This plus is the giant plus. And this is g. And ta-da, we're done. Okay, that's it. That's not complicated. Okay. And then the domain is the intersection. So I need to find the intersection of both of these. Okay, which is what they have in common. So it would be 0, okay, because that's where this one starts. And this one's not 1, so I can't have 1 either. So it would be this, okay? this would be the domain of f plus g. And in fact, this is the domain of all three of these functions, okay? So f minus g of x is going to be this with a minus sign, and f times g of x is going to be square root of x over x minus 1. Okay? And if you don't want to think about it as the intersection, you could just stare at these and find the domain like we normally do, right? Like this, right? I taught you how to find that domain way back in like section 1.3 maybe. Okay? So, it's really only when we divide where stuff could get a little cautious. Okay, so when we divide, this is going to be f over g, okay, which if we simplify it, becomes this, okay. We put parentheses there. So we see that we have an extra problem, right? This can't be 0 now, right? So the domain of this one is parentheses 0, 1, union 1, infinity, okay? So like literally the only difference is that. Okay. Now order matters on these, okay? So like for instance, if I wanted to know what's g minus f, well, it would I'd like I would write g and then put minus f, okay? And it would have this domain, okay? So order matters, all right? Make sure that it's f over g and you're not accidentally doing g over f, okay? Because that's like completely different. All right, okay. Let's do another example. Okay, so here I'm gonna have f is 1 over x squared minus 9. And g is going to be the square root of x plus 1. Okay. So if we remember the domains, okay, so the domain of this one would be -1 to infinity. Okay. And right, remember, you guys should know how to be able to solve that. Okay. This thing's domain, you should also be able to solve since that's a difference of squares. Okay. So the domain of this is -infinity, -3 to 3 to 3 negative to positive infinity. Okay. So these are the two functions and here's their domains. All right. The first three operations, okay, again, not hard. FG. Okay. You just kind of do them. So here's x plus 1, x squared minus 9. Here's this thing with a minus sign in the middle. And then here's this thing with a plus sign in the middle, okay? And all three of these will have domain the intersection of both of these. Or you can just stare at it, right? We need obviously to be greater than or equal to -1. But then from here, you know that you can't be 3. So it's going to be this. Okay? And then we do the weird one, right? The special one, the divided by. So it's going to get you divided by this, which, simplify a little bit, or at least make it look presentable, right? And then we can stare at this thing and be like, oh, the domain of this one is parenthesis -1. Okay. 3, infinity. Okay. So that's how we combine these. All right. Moving on. to here's the really important part of this section. Okay, so by far the reason this section is difficult and important is this concept or compositions. Okay, so definitely this is the most important part of the section. Okay, so composition, I'm going to introduce like a new operator. Okay, so an operator are like these symbols, right? They do math for us, right? We know these. Okay, the dot is multiplication, or some of you use x or asterisk, right? um this circle, okay, that circle means composition or to compose. Okay, so F compose G. All right, and we don't actually say the word compose, we say of. So like, right, we don't say plus, we say like we don't say add, we say plus, right? So instead of composition, we say of. So G of F is equal to F, okay? But we're gonna stick G inside of F, okay? So the right will go inside the left. All right, so here, this is where color coding becomes very important, okay? So here, I have F of X equals X squared. And here I'm gonna have G of X equal to 3X plus 1, okay? Now, remember when we were doing the difference quotient and I plugged in A plus H? It's kind of the same thing. Okay, so if I have F of G of X, okay, that's F, okay, and I'm going to stick G inside. All right, so G is this. Okay, so F of 3X plus 1. Okay, and F is that. So it's squared, and I stick this inside, and ta-da, it is this. Okay. Now, if you could have done that in one step without writing these two steps, that's perfectly fine. I actually don't ever write down this or that. I would just skip to the answer. But this is what you do, right? It's you stick G inside F, okay? And then if you wanted to, you can like FOIL, right? So like this is 9x squared plus 6x plus 1. All right, and again, order matters. So G of F of X is a different function, right? This is G, and I'm going to stick F inside. Okay, so G is 3 blank plus 1, okay? And F is X squared. So the answer, right, is 3x squared plus 1, right? And we look and we're like, yo, those are totally different. Those are not the same, okay? So the order matters, okay? Very important. So let's do one example more. Okay, so F, I'm gonna pick square root x plus 2, and G, I'm gonna pick x squared plus x plus 1. Okay, so let's do this one as blue. This one will be red. So F of G, or fog, right? It's also called fog notation. So it's F, and I'm going to stick G inside. So F is this thing, okay? Right? This is like an empty F. And I am literally going to like grab this thing and just put it in there. Ta-da! Okay. So you literally see how I stuck G and put F inside. Okay. So there you go. So then, I mean, you can simplify a little bit. So this is the square root of x squared plus x plus 3. And that's the answer. Okay. Now, let's do the other direction. So golf. Okay. So G, the empty G shell, looks like blank squared plus blank plus 1. Okay. And the stuff that goes in the blanks is this. Okay. And then you can simplify. So actually it's a little dangerous. You can ignore this, but like mathematically, that would be actually no. That would be this. Actually, we're fine. Yeah, okay. It would be this. Um it's just the domain is doing some secret stuff behind the scenes that you don't have to worry about. Ta-da! Okay. So that's f of g and g of f. Okay. Now, you should be able to plug numbers in. Okay, so here I'm gonna have f, okay, is gonna be 2x minus 1, and g is going to be 1 over x minus 1. Okay, and so a question I could give you is find f of g of 5. Okay, so like plug in 5. And there is 2 ways to do this actually. Okay. Option 1 is right. This is f of g of 5. Okay. So you can just do this in pieces. Like you can find out what's g of 5. So you plug 5 into this thing. So 5 minus 1, 1/4. Okay. Then, right, g of 5 is 1/4. So you plug in 1/4 into f minus 1, which is 1/2 minus 1. 1/2 minus 1, which is negative 1/2. Ta-da! And you get the answer. So g of f of f, g of f of g of 5 is equal to negative 1/2. Okay. Option 2 is you can find fog. Okay. So f of g of x is equal to 2, 1 over x minus 1 minus 1. And then just plug 5 into this. And then just plug in 5. 5. Okay, so 2, 5 minus 1, 2 over 4 minus 1, negative 1/2. And you see that they're the same. Okay? So you have 2 options. You can do it in pieces, or you can compose the function and then just plug in. All right? It doesn't matter which way you choose. You get the same answer. Okay? So just pick your favorite, and that should be fine. All right? Now, moving on to more examples, but now I have to worry about the domain. Okay, so some of you may have noticed that I didn't talk about the domain for a little bit. That's because it's complicated. Okay, so the domain of a composition function. Okay, so again, when you compose functions, you're sticking the right function inside of the left function. Okay, so outside, inside. All right, so what you have to do is step 1, you have to find the domain. Find the domain of f. Okay, the normal function. Okay, and let's call that a. Okay, so number 2 is you have to determine, all right, which values of g will give values of g of x in a. Excuse me, I meant values of x. Okay. And you call that b. All right, and then the domain is actually b. All right, so that's extremely confusing. So let me just kind of graph it out for you, right? So we have, right, remember this when I was like, this is what a function is, right? So here I have a domain, and here I have a range, right? And here's my function g of x, right? And it's doing stuff. All right, now if I stick that inside of f though, right? F is over here, and I'm taking stuff in the range of g and putting it in f, okay? So the fog is technically like doing this, okay? It's going from the domain of g to the range of f, okay? But the problem is that I do have to do this middle step, okay? So I need to make sure that the range of g is okay with the domain of f, because that's what I'm plugging into f. Okay. All right, so if that picture didn't help, let's just start doing examples. All right, so we have f of x, that's the square root of x. This one has domain 0 to infinity. We have g of x, which I'm just going to make this line. Right, we know that polynomials have domain negative infinity to infinity. So if I want to fog these, okay, that means I get this, right? Which actually I can just solve like normal, right? So if I solve this like normal, negative 2x greater than or equal to negative 4x less than or equal to 4. I mean 2. Okay, so we get the domain negative infinity to 2. All right, not bad. Not horrifying. If I do it the other way though, g of f of x, that means I'm sticking f inside of g, which means I have this thing. And then if we just stare at this, then it's obvious, right? The domain here is just 0 to infinity. Okay, so we see that the two domains are actually like dramatically different. Like they almost don't even intersect. Okay, but yeah. Like a tip, if you're a little confused, would be just to find the domain of the composition like as soon as you find it, okay? So don't simplify, just find the domain. All right, so here I'm going to do another example, okay? Slightly harder, but not really. F is going to be square root of x, and g is going to be square root of 2, we'll do 3 minus x, okay? So f of g of x is equal to the square root of the square root of 3 minus x, which we all know is the fourth root of 3 minus x, which that has domain negative infinity to 3. Okay, so that's not that hard. Now the other direction though, g of f of x is equal to 3 minus square root x. Okay, and that's a little bit more complicated because you're like, okay, automatically x has to be greater than or equal to 0. But then you also have to solve this thing. So 3 greater than or equal to square root x, 9. Right? So x has to be less than 9. Okay? So then you combine both of these and get domain 0 to 9. Okay. And then, okay, so just to get a little bit weird with it, wrapping up the section, we can do this, g of g. Okay, so I can stick g inside of itself, which that would be 3 minus square root 3 minus x. Okay? And then we can see what happens. Okay, so automatically, right, x needs to be less than 3 from here. But then we got to look at the whole thing. So 3, this thing, greater than or equal to 0. 3. Okay, square both sides. Add, subtract. So x needs to be greater than negative 3. Okay. So yeah, so x needs to be less than 3, but greater than or equal to negative 3. So that gets you negative 3 to 3. All right. So we get that domain. Now, I want to be very careful. Okay, I want to show one of the most popular trick questions. I've definitely put this on tests before for like my 124 class. Okay, but f of x equals x squared, and g of x equals square root x. Okay, so f of g of x would be f, so squared, and then g. And what happens is those cancel and you get x. Okay, but before you cancel and you look at the function, you notice that you still cannot plug in negative numbers. Okay, so the domain of this is 0 to infinity. Okay, and that's why way back over, I don't even remember, but in this example, I was a little freaked out by squaring the square root because technically my domain is still sliced in half. Okay, so even so, okay, this is also what I mean by like plug it in and then immediately find the domain, because if you were to simplify, this thing's domain is negative infinity to infinity, so you wouldn't catch it. Okay, all right, now if you do g of f of x though, then what happens? Then you get the square root of x squared. Okay, and if we look at that, the domain of this is actually negative infinity to infinity. Okay, but if you plug in numbers, you'll notice that the range is actually just the positive numbers. And then if you remember, like one of the first days of class, I actually told you this is the definition for the absolute value function. Okay, so this combination doesn't cancel out either way. Okay, if you do f of g, it looks like it cancels, but you only get half of the domain. And if you do g of f, then you get absolute value of x, you don't get x. Okay, but you get the full domain at least. All right, okay, so that's composing functions. Now, the last thing in the actual section is decomposing functions. All right, so if you're going to calculus or higher, this is actually very important that you like learn this skill, okay? I also call it having like the math eyes, because the complaint would be that you don't see things the same way that I see things, okay? So what you want to do is you want to have a function h, okay? And what your job is you want to make an f in a g, okay, such that when you do f of g, it becomes h, okay? So one way is just kind of obvious, right? You can kind of just stare at them, right? Like if you stare at a function, you can see a square root and then you can see like an inside chunk, right? So one of the most natural ways to decompose this would be f of x equals square root x, g of x equals 2x plus 1. Okay? And then if you do f of g of x, you'll notice that yeah, you get the square root of 2x plus 1. Okay? But you can do it other ways. Okay? So there's infinitely many, well, I don't know if, I mean, yeah, no, technically there is infinitely many. But right, I could choose x equals square root of x plus 1 and g equals 2x. Right, that's another combination that works. Technically, this is cheating and you will not receive credit, but you could make f of x equal to square root 2x plus 1 and g of x equal to x. Like that'll always work, right? Which is h of x, okay? It's just that's defeating the purpose, so you will not receive credit. Okay? And if you want to get ridiculous, you can actually go farther. So you can make f square root of x. You can make g x plus 1. And then you can make a q be 2x. And then now I've gone overboard, and f of g of q, okay, this triple composition is actually h of x also. Okay, so if I stuck all three of them inside of each other, I get back to h. Okay. So yeah, this is decomposing functions. It's honestly not that important for us, okay? If you're gonna go to calc though, then being able to like stare at a function and break it into pieces is like a valuable skill. Okay. So here, I have a function h. It's this. I want you to be able to break it into two pieces. Okay. So again, I hope you like can see like pieces of it, right? Like so you see the bottom, right? It's 2x plus 3, and then it's on the bottom. So I can make f just the flipping function. Okay? And then right, if you do f of g of x, you get back there, which is h of x. Okay? So there's really like no math involved. It's just, can you like dissect the math equation? All right. But yeah, that's decomposing functions. And that's really it for section 2.6. 2.6. Yes. All right. So yeah, that's it for 2.6. The first part's important, but definitely be good at composition. Okay, be able to stick g's inside of f's and tell me domain. Okay. But yeah, that's it. See you guys next class.